Thank you very much, Don. It's a pleasure to be here, a pleasure to speak with some of my Stanford colleagues, and I'm very excited to present to you guys highlights in AI from the 2025 AI Index report. Now, before we actually begin, I think it's good to walk through what this report is, what this initiative is. This report came out in 2025, very recently, a few weeks ago, but it's something that has been around now for a while. The first report came out in 2017, and it was created then by a diverse committee of AI thought leaders, people like Jack Clark, who's one of the co-founders of Anthropic, arguably one of OpenAI's biggest rivals, Eric Brynjolfsson, who I would say is one of the world's leading AI economists, James Manika, who is currently leading all of Google's AI research activities. And these individuals came together in 2017 because they understood, as far back as then, that AI was going to be a transformative technology, and that as such, it was really kind of valuable and necessary to have a report that could really paint a picture as to what is happening with this tech. And that's exactly what we aim to do. The report is close to 500 pages, and we really aim to kind of track in a longitudinal way what is happening with this technology and how it is evolving. To do that, we collect our own data, but of course, we collaborate with data vendors from across the world, some of which are listed here. And we've been privileged over the years to have been cited by newspapers across the globe. As well, we are very frequently cited by governments and government agencies across the globe. And increasingly now, we've also been speaking to business leaders from across the globe that are really interested in kind of understanding what's actually going on with AI and how the technology is changing, evolving, growing, and some of the ways in which this kind of landscape is looking a little more differently than it maybe has in years past. Now, with that said, let's actually get into the top takeaways of the report. You know, the full report, as I said, is close to 500 pages, and I could probably spend, a few days walking you guys through all the highlights, but I'm going to perhaps do you a service and give you some of the top takeaways of the report. Now, I hope this doesn't stop you from reading the report. I mean, I wrote most of it, so I would love to imagine that all of you guys are going to go home after the talk today and just rifle through the 500 pages. But presuming that you guys, like me, have busy lives, these top 10 takeaways, I think, will try to distill it a little bit more for you guys. Now, first and foremost, I think we could say that AI performance is really continuing to improve. Now, there's a lot of different ways in which you can kind of look at this and measure this, but one of the ways in which we like to do that at the index is by looking at the performance of AI image generation. So one of the things that we did at the index is we went to Midjourney, arguably one of the world's leading text-to-image generators, and we asked Midjourney to generate for us a hyper-realistic image of Harry Potter over time. And we asked each version of Midjourney this question from the first version that came out in February of 2022, all the way to the most recent version. Now, I think this slide really kind of juxtaposes how much better AI technology has gotten. Now, personally, if I were to actually hang one of these in my living room, I'd probably go with the one on the left. I mean, it looks like Pablo Picasso has drawn me a tortured Harry Potter, definitely more of a conversation starter than the one on the right. But of course, if you're looking for hyperrealism, which is what we asked with the prompt, it's the one on the right that wins at the end of the day. Now, it's not just enough to kind of look at broader questions of image generation. What do the benchmarks tell us? Now, this chart is actually from last year's report, and it kind of looks at how well these AI systems are performing on benchmarks or kind of intellectual tests of their abilities. And you'll notice that already in 2024, on a majority of these benchmarks, we could say that the performance of leading AI systems exceeded that of humans. But there were still some benchmarks, which you see on the far right, where humans were still performing better than AI systems. Fast forward a year later, and you could really say that there don't remain a lot of benchmarks left where human capability exceeds the performance of AI systems. And in fact, some of the new benchmarks or tests that were introduced in 2023 that were designed to explicitly challenge these AI systems with really hard questions like GPQA, like MMMU, like SWE-bench, have all seen massive performances in the last year. And the story here isn't just one of AI systems exceeding humans. It's also a story of the pace of the gains also massively going through the roof. For the benchmark on the left, the one in the blue, this is the benchmark for image classification. And you'll notice that it takes the AI community a good 4 to 5 years to go from performance that is roughly 10% relative to the human baseline to exceeding that. Whereas for this benchmark, one of them that's on the right, the benchmark in teal for competition level mathematics, we get AI systems that go from 10% relative to the human baseline to basically exceeding that baseline in 2.5 years. And for reference, the performance benchmark or baseline for that particular test is the performance of a 3-time international math Olympiad gold medalist. So it's not like I'm at home and I'm doing these questions and basically they're testing these systems against me. They're testing them against people that actually know how to do some of these things. And the takeaway for me from this is twofold. I think one is that even if AI were to stop getting better today, which it won't, I mean, we saw how it got from this to basically this in a year, you already have a very powerful technology. But we can anticipate that the developments are going to continue, that the tech is going to get better. And this is just kind of signaling the rapid pace of improvement that we've witnessed and seen in recent years. Now, as AI technology has gotten better, it's the case that AI has become increasingly embedded in everyday life. And I think you see this in a lot of different ways. So, for example, the number of AI-related medical devices that have been approved by the FDA has skyrocketed dramatically in the last few years. Similarly, self-driving cars are now kind of a reality. If you look at, for example, information on how many Waymo miles have been driven in comparison to a variety of human benchmarks, you'll see that Waymo is being ridden a lot. In a lot of cases, it's safer than kind of using or being with a human driver. And this isn't something that's just limited to North America. In places like China, you've also seen a massive rise in self-driving cars. Baidu, for example, has become a lot more prominent and a lot more popular. So the tech is getting better. And as a result of the tech getting better, it's become more and more a part of all of our lives. Now, the story of the tech getting better isn't just one of people are seeing it more in their daily lives. I think one of the big narratives that we've seen in the last year is also increasing interest in business. And this is again reflective of the fact that we have now a usable technology at our disposal. If you look at global private investment in AI by geographic area, this is again going through the roof in virtually every single geographic area that we've measured, with, of course, the United States leading the charge. If you look at total global private investment in generative AI, you go from roughly 5 billion of this investment in 2022 to 34 billion in 2024, a massive increase. And perhaps most significantly, the number of businesses that say that they use AI in at least one function has also massively gone up in the last year. This was actually a really interesting data point because we've worked with McKinsey in the last 5 to 6 years to collect this, monitor this, and analyze this. And you'll notice that in that time period, there's a relative plateauing of how many businesses reported using AI. Well, that plateauing is no longer the case. In the last year, usage has really skyrocketed. And this is, again, reflective of the fact that businesses across the world are thinking critically about this technology and really trying to kind of understand how to use it. And in a lot of ways, this kind of business usage of this technology is reflective of the fact that there is now a lot of literature that is convincingly showing that AI has positive productivity impacts. There are studies that have looked at the impact of AI on customer support agents and found that those that use AI get a lot more done than those that do not use AI. There have been studies that have looked at the impact of AI on scientific innovation, finding that AI-powered scientists discover more new materials, file more new patents, and are just more productive than those that don't use AI. And it's not just these domains. You see these studies in computer science, you see these studies in finance, law. There are so many domains that really kind of illustrate well just how much AI is kind of driving the productivity revolution forward. And that's something, of course, that's exciting businesses across the world. Now, another topic that inevitably comes up when you mention AI to kind of different audiences and different stakeholders is the geopolitical question. Who's leading in AI? What countries are ahead? Which country is in a position to best dominate this race moving forward? Well, we can really say, looking at the data, that the US still leads in producing top AI models, but the performance gap is closing, especially with China. So if, for example, you look at the number of notable AI models by select geographic areas, you'll see that in the last year, there were more notable models that were produced from the United States than any other country. There were more from the United States than, let's say, China or France. And looking at that trend in the last 20 years, you see a very similar differential. When you look at the number of notable models by geographic area, the total that have been passed in these various years, again, it's really the United States that's far ahead, China in second, and several European nations alongside Canada that kind of round out the rest of the finishers. But again, you can't just look at who's producing the most models. You also need to consider what is the quality of the models that are being produced. And one of the interesting things that we did in the index this year is we looked at and juxtaposed the performance of the top US versus Chinese models on LMSys. So LMSys is a benchmarking platform that allows the public to rank and compare different AI models and to kind of basically comment on the degree to which one model is better than the other. It's a very popular tool for actually assessing which model is preferred by the broader community. And you'll notice that in January of 2024, there was roughly a 150 point differential between the best US and the best Chinese model. That differential has decreased quite substantially in the last year. So we can affirmatively say that China is really catching up when it comes to these AI developments. There's also certain areas where China historically does very well. It tends to lead in terms of producing the most AI publications in the world. It also tends to lead in producing the most AI patents in the world. So I think that when you look at this performance gap, there are some areas where the United States is still very much further ahead, but other notable areas where China is catching up on and leading. So this kind of question of the geopolitical dynamic between these two countries is going to be an interesting one to continue to pay attention to in the near future. Now, a few years ago at the AI Index, we decided to include a completely new chapter on trends in responsible AI. This is a new area, a new topic, and one that is gathering increasing salience as AI becomes rolled out more and more in day-to-day life. Now, one of the things that we find at the index is that the responsible AI ecosystem is really unevenly evolving. Now, there is more interest in responsible AI, partially because the number of reported AI incidents is going through the roof. That's made very clear in this chart. There are more stories of Tesla's malfunctioning, perhaps issues of data leakages to romantic chatbots, or perhaps issues of chatbots suggesting that certain teenagers take their lives. These are all incidents that have happened in the last few years. Now, in the backdrop of these kinds of rising AI-related incidents, one of the things that we find is that there is not a lot of standardization in the responsible AI ecosystem as it relates to what particular models are being tested on what particular benchmarks. So if you look at general capability benchmarks for popular foundation models, so these again are benchmarks that are looking at How well can these models, for example, understand language? How well can they do scientific reasoning? Every major model is tested on a few of these benchmarks. For example, MMLU, GPQA, and MMMU. There is pretty high levels of standardization. But when you flip the script and you look at benchmarks for responsible AI, benchmarks that are trying to assess how biased are these systems, what is the likelihood that they emit toxic responses, what is their vulnerability to adversarial attacks, you'll notice there really is no consensus. Some developers are testing on some benchmarks and others still on others. Now, the index isn't suggesting here that these developers don't take responsible AI seriously. A lot of these developers have legions of teams that are working very diligently and very, let's say, critically on issues related to responsible AI, but we're looking at an ecosystem that is quite fragmented. Some developers are testing on some benchmarks, others still on others, which means that if organizations are thinking critically about deploying these systems, they really kind of need to ask themselves, okay, what are the ways in which I want to use it, and how can I be doing perhaps my own internal testing to ensure that we know in a very comprehensive way what some of the risks are with these systems. Now, in the absence of this standardization, what you've seen is increasingly the emergence of a lot of academic benchmarks coming from academic institutions like Helm. Helm Safety, for example, ranks how safe various models are, or other benchmarks like AirBench that have also been released. Now, it's not just a question of the developers of the model not having consistent responsible AI perspectives or parameters. It's also a case of the actual kind of deployers of the models. If you look at data from McKinsey, which surveys organizations and asks them on AI-related risks, for example, do organizations consider certain risks to be relevant versus are they working to actively mitigate other risks? You'll notice that there is a very sharp discrepancy. There is a lot of risks that are considered to be relevant, but a lot less work is being done to actively mitigate these risks. And this, I think, is reflective of the fact of perhaps the reality that a lot of these organizations simply aren't in the mature phase of their AI rollout, but still the responsible AI approach is lacking. Now, one area globally in which there has been encouragingly a lot of exciting developments on the responsible AI ecosystem has been on the front of RAI policymaking. 2024 was really a banner year in that a variety of international stakeholders, from the OECD to the European Union to the United Nations, they did a lot of work to release global standards and global frameworks on how different countries and different institutions across the globe should be thinking about and conceptualizing RAI terms. Now, this kind of ties us nicely into the sixth point, which kind of looks at global AI optimism and trends in public opinion. One of the things that we show in this year's index report is that although global AI optimism is rising, there are still very deep regional divides that remain. So this chart is looking at answers to an Ipsos question by year, which is to what percent or to what extent do respondents agree that products and services using AI have more benefits than drawbacks by country? And you see in the points the responses for every single year, and you see on the right-hand side the point change from 2022 to 2024. You'll notice that for most of the countries in the sample, there is more optimism now than there was in 2022. And there has been especially sharp increases in a lot of countries like Australia, Canada, France, and Germany that historically were quite pessimistic about the technology. Still, there are fairly sharp regional divides that remain. For example, if you look at it, there are certain countries like China, Indonesia, and Thailand that are substantially more bullish about this technology than some of those aforementioned nations. And as we kind of think about how this technology evolves and what some of the implications of its evolution are, it's going to be increasingly important that we kind of ask and disentangle how different countries across the world are thinking about this kind of tech. Now, all this kind of discussion of business usage of AI, this discussion of technology becoming better, it also kind of underscores the fact that it's not just a question more recently of AI technology becoming better, but AI technology has really become a lot more efficient, affordable, and accessible. And you see this in a lot of different ways. So one of them is falling inference prices. So the inference price refers to the price a user has to pay to query the model. And here we're looking at a weighted average of input and output prices. And you'll notice that for a model that scores the level of GPT 3.5 on a task like MMLU, this is the line in the blue on the left, we go from a cost that is roughly $20 per million tokens in November of 2022 to a cost that is 7 cents per million tokens in November of 2024. That is a massive decrease in 2 years, and really illustrates to you how much some of these inference prices have fallen. And part of the reason that we have falling inference prices is because we're seeing a world of higher performing smaller models. So if you look at, for example, the smallest AI model that scores above a 60% on MMLU, you go from a model like Palm, which was released by Google in May of 2022, that had roughly 540 million parameters, to a model like Phi-3 released by Microsoft in May of 2024 that had roughly 4 billion parameters. The fact that these AI researchers are able to squeeze increasingly greater degrees of performance from increasingly smaller models means that costs, both in terms of training and deployment, are decreasing. And again, a lot of these efficiency gains have been achieved by better hardware. If you look at the energy efficiency of leading machine learning hardware, you see continual growth over time. This leading hardware, state-of-the-art hardware, becomes more and more efficient with every year. And as it becomes more and more efficient, the price performance of these various points also increases. So if you juxtapose hardware that, for example, was launched in 10 years ago, some of these earlier GPUs, they perform at a much worse price performance point than those that have been more recently released by some of these major companies. And it's not just a case of there being better performing smaller models. Another big thing that kind of drives the openness angle forward much more so is the fact that there has been a pretty sharp decrease in the performance gap between the top closed and open weight models. So one of the big narratives when we looked at AI in the last year is that there was a lot more closed weight models that were performing a lot better. So if you were an organization and you needed to make a choice of, do you build with a closed weight model that you cannot modify freely, you cannot kind of host the weights locally, or do you perhaps build with an open weight model? In a lot of cases, you really had to sacrifice performance if you were deciding to build with open weight systems. That really no longer is the case. As was illustrated with the Chinese model example, the gap between the best closed and open weight models has massively shrunk in the last year. Now, the technology has gotten better. It's become a lot cheaper. Businesses are using it more. We're seeing it more in all of our lives. And governments across the world are correspondingly stepping up on AI. And you see this both in terms of regulation and investment. So if you look at the number of AI-related regulations in the United States, you see a very sharp increase from one such regulation in 2016 to 59 in 2024. And these regulations, very importantly, come from a diverse range of US regulatory agencies. So it's not the case, for example, that you just have one or two agencies that are thinking a lot about this. You have regulations that come from the Centers for Medicare and Medicaid, regulations that are coming from the Commerce Department, regulations that are coming from the Executive Office of the President, regulations from the Health and Human Services Department. Agencies across the board are thinking very carefully about AI. And this is a sign, again, that if you're thinking about using AI, you really have to understand that it's a multi-purpose technology that regulators from multi-purpose perspectives are going to be thinking about. And you see this regulatory interest in a lot of other verticals. State level legislators across the United States have also responded by passing more AI related bills into law. You see that very clearly on this chart. And since 2016, you have certain states like California, Utah, Virginia, and Maryland that have really kind of led the charge in this particular domain. You see a similar trend across the globe. The number of AI-related bills passed into law across geographic areas in the world has also kind of massively increased. And it's a similar story with all these charts. We go from 1, 2, 3 bills roughly a decade ago to fairly high volumes in the present moment. Now, even when I kind of gave this presentation last year, for previous versions of the AI index, one of the big narratives was the fact that regulation is increasing. This isn't a trend that is necessarily new or surprising. But one of the newer trends that we're seeing this year is governments across the world stepping up in terms of AI investment. And you see this in so many different countries. Singapore announced in February of 2024 a plan to invest $1 billion in AI over 5 years. Abu Dhabi has launched a $100 billion AI investment firm. Canada has pledged roughly $2.5 billion to invest in AI infrastructure in the country. China has created the country's largest ever state-backed investment fund to back its semiconductor industry. So it's not just a reality where regulators are saying, okay, we need to set rules about how we want to use this technology. It's also a reality where a lot of these governments are thinking to themselves, okay, how can we make tangible bets about investing in this technology so that we could reap some returns with it? And one of the things that we did at the index this year for the first time ever is actually look at how much different countries across the world are spending on AI related contracts. And the United States is far and ahead the leader, but a lot of European nations have caught up. And when we move into a world in which AI is going to become increasingly a priority of governments across the world, it's important that we kind of really ask ourselves and try to very concretely understand how a lot of these kind of differing stakeholders in the world are thinking about AI, using AI, and thinking to themselves what effect this technology might have. Now, when you look at this kind of analysis as it relates to contracts, it's important to also kind of look at data on AI-related grants in the United States, and this kind of paints an even kind of clearer picture, or even clearer perspective. The number of AI-related grants that you see in the United States has increased steadily year over year. It'll be interesting to see what this chart looks like next year with all the confusion that is occurring now in the federal government. But the important kind of takeaway here is that AI, at least in the United States and really in a lot of countries across the globe, is becoming an increasingly kind of salient, important, and valuable research topic to consider. We were very excited this year at the Index to partner with the Kapoor Foundation to launch a revamped version of the AI and education chapter. And there are just so many interesting takeaways here when we think about trends in AI and education. And one of the takeaways is that there are still a lot of gaps that persist in AI access and readiness, despite the fact that AI and computer science education is expanding. What you see on this map is the availability of CS education by country. There are certain countries that mandate CS education in primary and secondary school. Other countries where it's mandated in some school districts. Other countries where there really isn't a lot of high-level computer science education that is available. So we're looking at a global ecosystem that, at least from an education perspective, is quite fragmented. I mean, every year we see more and more new CS post-secondary graduates at the bachelor's, master's, and PhD level. It is difficult to get this data just for artificial intelligence, but the talent pool of individuals that are thinking about AI and working on a lot of these problems is increasingly rising. But I spoke about some of these access concerns. The number of kind of teachers who, for example, report feeling equipped to teach AI-related topics by grade level is still very low. Basically, a third of teachers in the elementary school level say that they feel equipped to teach AI. Roughly half of middle school and high school teachers feel similarly. If we want to build to a future where people are going to be ready to embrace AI and to think strategically about this technology, it's important that we empower teachers to make good decisions about this tech and to think about it well as well. Now, I spoke earlier about how one of the big stories of AI in this past year was the fact that AI has become a lot more efficient, open, and accessible. And that's certainly the case, but it's also the case that industry is continuing to race ahead in AI. Now, there are some caveats to that. If you look at, to start, the number of notable AI machine learning models that have been released by different sectors, you'll notice that there are substantially more models that have been released by industry actors compared to models that have been released by academic actors. We basically kind of see that until 2014, there was roughly mainly academic institutions that were leading the charge. And then as of 2024, a fairly substantial gap has opened up between these different institutional affiliations. Now, if you look at the number of notable AI models by organization as a sum in the last decade, it's really organizations like Google, Meta, and Microsoft that are leading the charge and far outpacing the output of a lot of other notable academic institutions in that time period. And one of the interesting kind of pieces of analysis that we did in this year's AI Index, to look at it more from a geopolitical lens, is looking at which countries are releasing the most highly cited AI research. The United States is far ahead. China is in second, unsurprisingly. But again, in most of these countries, industry does well, but actually a lot of the most highly cited research is coming from academic sources. So, it's one thing to kind of say that industry is leading ahead, but there are still certain domains where academic actors are doing a lot better. And now part of the reason that kind of industry is really in a position to kind of continue race ahead with AI is that there are simply kind of massive computational costs that are associated with training a lot of these models. You kind of go from training costs that were, very low a few years ago to now the ones that are massively higher because the compute bill of a lot of these systems is going through the roof. And you see this kind of quite nicely when you look at, for example, the total power draw required to train these systems. It is also kind of increasing year over year and continually rising. And yes, it is the case that a lot of models now are becoming increasingly smaller, increasingly kind of more nimble, increasingly more efficient. But it's also the case that at the frontier, a lot of these models still cost a lot of money to train. You go from models that are roughly $1,000 in 2017 to models that cost anywhere from 1 million to 12 million in 2022 to models that in the last year cost $40 to $200 million. And that's an interesting thing to kind of observe and an interesting thing to know. Now, still, if you're looking at some of these models at the frontier, they're still quite expensive, right? So, if you want to use models that aren't necessarily giving you, let's say, the state-of-the-art performance, you can get models for very cheap, but models that are kind of at the frontier level that are really kind of state-of-the-art in terms of their performance capabilities, those are still quite expensive to use. Now, when you talk about some of these kind of differing industrial trends, one of the key things to find as well is that there really has been a tightening at the frontier in the performance of AI systems. And what is meant by this is that if you kind of look at the AI ecosystem in 2022, for instance, there were probably a few players, I would say kind of Google, OpenAI, that were really kind of in a position to dominate this particular race. Now we're kind of looking at an ecosystem that is increasingly tight. There's 7 or 8 different kind of players that are really kind of well situated to kind of be producing a lot of these high performing top models and top systems. And the race is becoming increasingly tight. All these developers produce very, very strong systems, and the kind of delta between the best system from one developer and the best system for another is kind of massively shrinking over time. A few more kind of highlights, extra ones sprinkled in before I open it up to questions. You can't talk about AI in the last year without talking about the impact that it's had on science. So you see this in so many kind of different ways where things like AlphaFold, they've become a lot more successful at discovering protein structures. That's what you see on this particular chart. And the AlphaFold research was awarded with a Nobel Prize in Chemistry in 2024, as was research in reinforcement learning that was given to Jeffrey Hinton and others in the space. And last but not least, in this presentation, I think I've kind of spoken to the fact that AI as a technology has gotten a lot better and has become a lot sharper, but it's still important to kind of be honest with ourselves about what some of the challenges with the technology are. There is one really good benchmark that we look at in the index called Plan Bench, which is a benchmark that assesses how well these systems are able to plan and engage in different kind of complex reasoning exercises. And you'll notice that on a lot of these tasks, there's a pretty high delta between how these systems are able to perform. Planning, of course, is an essential part of kind of human cognition, and there is still kind of important, perhaps, limitations that exist with some of these systems and limitations that we need to understand if we're in a position to kind of fully evaluate what these systems can do. So that kind of concludes the presentation. I've kind of intentionally left a lot of time at the end for questions, because I find that there tend to be a lot of good ones that come from different audiences. So I'd be super happy to field any of these questions now and perhaps open a bit of a discussion on what is going on in AI and see if there's any particular things that you guys are interested in discussing or understanding.
And please feel free to post your questions inside the chat or unmute yourself if you do have any questions.
Yeah, I have a question.
Yeah, go ahead.
Thank you so much for the excellent talk yesterday. I really enjoyed it. The presentation was very good. So my question is, how much credence do you think governmental agencies put in reports like this? And how do you think, what's the best path forward for presenting information to them, keeping in mind that it's not just AI systems improving, but the pace at which they're improving is also faster, so that the regulations will increasingly be placed and outdated?
Yeah, it's a great question. In relation to the first point, I mean, I would certainly hope that governments put a lot of credence in this report, and I think the data suggests that they do, because our report does get widely cited by them. In terms of how they should kind of react to this information, I mean, it's not the position of the index to offer any kind of concrete advice on what government should do. We don't kind of have that normative or opinion-based function. We kind of see our job as kind of commenting on where the ecosystem is, where it's going, and how it's evolving, so that decision makers can then make the right kinds of decisions. Because the data can tell you one thing, but then at some point you might need to make your own decision. If you look at, for example, this data of AI technologies improving and the capabilities getting better, one particular reaction to that might be, well, it's getting a lot better, we need more regulation. Another reaction to that is, well, it's having all these massive impacts, so let's use it even more, right? Depending on kind of what your policy priorities are and how you see the world, you can react to the information in different ways. but we want to kind of be a resource for the community to make good data-driven decisions in this technology. Don, do you want me to read the questions from the chat or myself, or should you facilitate that?
I was about to ask the same thing. If you would like to read the questions from the chat out loud, please feel free.
Sure. So Amela asks, what is the best AI model to upload a protocol document and then have AI summarize certain things for you? So that's a great question. And I think it kind of illustrates the fact that, I mean, I would answer that there's a lot of good models that could do that. I don't know necessarily what the best is, and it depends on what you need to be using it for. So kind of taking a step back, a lot of these benchmarks that we have that are kind of trying to assess what these AI systems can do, they're benchmarks for very kind of rigid and hyper-specific academic tasks. For example, how well can these systems do grade 8 mathematics? How well can they answer college-level reasoning questions? We don't have a lot of benchmarks for professional tasks that professionals might be doing, like summarizing documents. So that's kind of one thing to kind of, admit there. Now, the performance of models on other intellectual tasks might kind of, serve as a signal that can tell us how well they can do some of these other things. But I mean, as I showed you in the presentation, we're in a world now in which there is 5 or 6 different leading frontier models from all of these companies that I would bet could do that tasks at a pretty good level. Now, the question of best is, again, relative to what your organization is prioritizing with that task, right? Are you trying to, prioritize clarity in how you communicate things? Are you trying to prioritize concision? Are you trying to perhaps prioritize in-depth explanation? Depending on what goal you're trying to go after, the question of what is the optimal model to use might differ. Now, if you really want to know, your organization would have to kind of run some kind of internal experiment to really figure out what model is best suited for that task. Now, I help a lot of organizations do these kinds of things and kind of advise them on these things, but I would say more broadly that probably most of the leading models now from OpenAI, Anthropic, Google, they probably would be able to do that task pretty well. You should, of course, still have a human in the loop, but depending more specifically on what your organization is trying to optimize for, there might be certain models that are better suited for that function than others. Jason now is asking, was there anything that surprised you this year? That is a good question. I think what really has surprised me is, I think the kind of point about the models becoming a lot more cheaper, efficient, and more accessible. Because I think when I was writing the report last year, one of the big kind of themes was just the massive cost associated with building these systems. You were looking at training costs anywhere from $50 to $200 million. And when you look at training costs that are so substantial, it's easy to kind of think to yourself, well, where is this going to go and how is the ecosystem going to evolve? And I think there were kind of open questions as to like who could realistically afford to even build these systems in the near future. Now, it's still the case, as I have mentioned, that a lot of these frontier models are the most expensive ones. But it's also really the case that you now have a lot of really high performing systems that are becoming increasingly cheaper. And this has been achieved by better hardware, as I've mentioned. It's also been achieved by more high quality open weight systems. So I didn't kind of really anticipate that that would kind of happen as quickly as it did. There's another question that is asking, any recommendations on the best AI model for analyzing qualitative data? Again, I think I would have a similar answer. They're probably all fairly good at doing that. I think depending on the specific task you're interested in doing, some models might work better than others. If you really want to know empirically, you would have to kind of organize an internal organizational experiment, but there's probably less arduous ways to figure that out. I think that's a hard question to answer without knowing more about like what kind of qualitative tasks you're trying to do. But if you want to reach out to me offline, I can post my email in the chat and I'm happy to kind of discuss with you guys some of the different ways in which we can answer some of these questions. Teresa is asking a question. Is there an organization that tracks jobs lost versus created? So great question. No, to my knowledge, I haven't seen any kind of information on this particular question. And this is really kind of an interesting one to ask ourselves about. Now, I personally think, this is just my own opinion, I think that while AI is going to change the way in which a lot of work is done, I don't think that it is going to lead to massive job loss, at least anytime soon. There's a few reasons for this kind of thesis of mine. So I think first, historically, if you look at technological improvements have led to increases in quality of life and consumption, and they've led to decreases in hours worked, but not total elimination of jobs. And there was a very famous British economist in the 1930s, John Maynard Keynes, that predicted that 100 years from now, we'd all be 8 times richer and we'd all be working 15-hour work weeks. Now, the first part of that prediction is right. We're all 8 times richer, but I don't know about you guys, but I'm not working 15 hours of work a week. You know, what tends to happen is technology gets better, but we also then kind of increase our standards, right? When you had to wash a shirt by hand, you're probably maybe wearing a shirt a few times before you actually wash it. Now, a lot of us have laundry machines in our own homes and we'll wear a shirt once and kind of throw it in the laundry bin. So technology gets better, but it also kind of increases the standard with which all of us live. I think second, my own experience kind of shows that when you level up technologically and you save yourself time, very often I think organizations are going to reinvest that time to do other things. I mean, the AI index is a good example. I've been doing the index now for 4 years. When I first started, there was a team of 2 workers that were basically writing a 250-page report. I was one of the 2 workers. We still have 2 workers, but the report is now close to 500 pages, and we do way more promotional events than we ever have before. So with the same amount of resources, we have, doubled, if not tripled our output. And part of the reason that we're able to do that is because our team uses a lot of AI and our team has become a lot more productive. So very often when you increase productivity, you do save time, but a smart organization is going to be thinking of reinvesting that time to other functions. And thirdly, if you actually look at the data, McKinsey does have some interesting data on this kind of question of do managers predict that AI is going to kind of lead to more jobs or less jobs? And they've been asking this question year over year. And in 2023, I think 43% of managers predicted that AI was going to lead to job decreases. This year, I think that number has dropped to 30%. Now, there's still more predicting job decreases, but there is less that are predicting that. And if you talk to a lot of people in the field, they'll tell you, well, we're using AI and it's saving us a lot of time, but we're reinvesting that time to do other things. And the final kind of point that I'll make on this is, we really kind of need to ask ourselves, what can AI do intellectually? And what is the current kind of thought paradigm of AI well suited to achieve intellectually? Right, like these AI systems, they can answer any kind of test-based question better than you. But with all of our jobs, there's a lot of kind of tacit task in terms of answering an email, networking with another individual, that we don't really have good AI systems that are kind of able to do that really well and really effectively. So are we ever going to have AI systems that are going to take away those skills? I don't know. So I personally feel, to kind of answer your question in a different way, I feel that while the type of work that we do is going to change, and I think that managers that use AI are going to replace those that don't use AI, I still think there's going to be a lot of jobs for us. So unfortunately, for those of you that maybe had banked on retiring and becoming painters in the next few years with the AI revolution, I don't think that will happen, but I'd love to be proven wrong on that one. Max is asking a question: to what extent is fine-tuning models becoming less important, perhaps prompting becoming relatively more important as they get more capable overall? So fine-tuning is kind of referencing, you have a base model, you can then kind of train it on your own data, or perhaps adjust some of the parameters to optimize some hyper-specific function. I mean, it is becoming less important in some ways, But again, it depends where your organization is at in the stack, right? You know, if you're doing a lot of workflows that are using AI, you know, cost might be a very important function for your organization. And maybe for your organization, rather than kind of building with a reasoning model that is incredibly expensive to use, you might prefer to use a lower performing base model that is then fine-tuned on your own internal data. So I still think fine-tuning can kind of lead to a lot of very strong results, depending on the kind of task you're trying to achieve, and generally kind of where you are in the kind of AI stack of what your organization is trying to do. Camel is asking, what are the impacts of US-China issues where US is limiting China's access to latest technology, specifically as it relates to AI? I mean, I think there's different things to be said about this. I think there's one thing to kind of be said about the effect of chip controls. I think that we're going to start seeing those chip controls have more and more of an effect as time goes on. But again, a lot of Chinese researchers, especially in the domain of AI, have historically been very good at taking AI model insights from the US and other countries and really optimizing them. And in a lot of ways, that's really what the kind of launch of DeepSeek represented. DeepSeek wasn't necessarily a new way to build models. It was the same way of building models at a substantially lower cost. And that has a lot of important impacts for where this system could go and how it might develop over time. So that's one thing. Also, I mean, a lot of this technology is kind of open and diffuse, right? The kind of DeepSeek authors, they had a very transparent kind of disclosure in their papers about how they build these systems, how they think about these systems, the different things that they're kind of optimizing for and thinking about. And in reading the paper, you could certainly learn a lot of information about how these systems perform and where they are kind of in the system. So I think that some of these technical restrictions are certainly going to affect how the technology develops. But I also think that there's a lot of kind of open sharing of insights that can still encourage a world in which the technology blooms and is spread fairly openly. Vincent is asking, as AI regulation is increasing, can you please comment more on the balance between regulations and innovation? How do you navigate perhaps conflicting local regulations in a world where AI tools can easily be launched globally? Yeah, this is an excellent question. I mean, it's just a challenge, right, that organizations are going to need to be thinking about. So on the one hand, I think one of the things that you kind of find is that there is a lot of this data that shows that AI is associated with more productivity. It leads to kind of better outcomes and optimizes a lot of things along the value chain. So that's, I think, one of the important things that's, you know, that you want to highlight. So organizations might see that data and they kind of might really think to themselves, okay, how can we kind of now roll out AI to achieve a lot of really good things? Now, on the other hand, yeah, you see this kind of rise in regulation, you think to yourself, well, you know, how do I use AI in a way that is kind of compliant? And I mean, it's hard right now because a lot of the regulation is evolving and there really isn't a lot of consensus as to what you can and cannot do with the tech. So I would say that it's a difficult thing to balance, but it's something that needs to be done, I think, for several reasons, right? I think, you know, you need to be thinking about AI as something that's going to be around for a while. It's not going to go away. So if your organization is thinking about using it, you do need to kind of invest in good governance and regulatory mechanisms. And that's not something that you could really kind of patch onto the product after you figure out how to use it. Of course, you're always going to have to prioritize usability first, but thinking about some of these governance concerns from the get-go is also going to be really important and really salient. So it is a very challenging thing to do, but I do think that kind of operating with this balance and kind of, you know, dialoguing with it is going to be substantially more important and substantially more valuable than just kind of emphasizing usability above other things and other points. Christy is asking, how will trends you're seeing in Q1 2025 impact some of the measures we saw today? Well, I think for me, you're going to see continued technical improvement. You're going to see continually greater degrees of AI embedding in life. You're going to see continued use of this technology. I think one of the big things that I'm really interested in understanding is, what is the actual kind of ROI of this technology going to be? I mean, we've seen a lot of evidence that in small study settings, the technology does have a lot of strong productivity impacts. But kind of zooming out, I would love to learn a little bit more of, yeah, like to what degree is it actually going to move the needle from an ROI perspective? What companies or industries are perhaps going to be most able to kind of take advantage of the technology and put themselves in a position to use it well? And more broadly, kind of some of these questions and points, that's one of the things that I'm kind of quite interested in understanding and seeing. So I think that's all the questions that I see there. Again, thank you for the invitation and really enjoyed speaking to your group today.